So we kind of quit halfway through worksheet 4 yesterday. This is still a part of the 2.2 section of the quiz, part of the polynomial business. Besides, you know what, let me do a tiny little. If we had this equation, can you tell me what degree that is? This is a warm-up. Wow. Okay. I'm going to put a negative out here. Okay. So it is a negative. There's an x squared. This parenthesis, when you squared it, would have an x squared. This has an x. So it is a degree 5 with a leading coefficient of -1. So can you tell me the end behavior? What is it doing on the left? Degree 5 means the two ends are going the same way or opposite ways? Opposite ways. Normally, an odd degree would be like this, right? But it's negative, so it's doing this. Okay, might be doing some loop-de-loops in here, but it's going down on that end. Okay. What else could you tell me a little more accurately based on the zeros? What are the zeros? And if I set this equal to 0, there's a 0 at 0, right? So there's a 0 of multiplicity 2. There's a 0 at 5 multiplicity 2. Everybody get the multiplicity? It's just the exponent power. And if it's even, it means what? Bounces or just kisses the x-axis. Okay? So I now know at 0, because it's multiplicity 2, it's doing a bounce. At 2, nope, just kidding. At 5, it's multiplicity 2, so it's doing a bounce. And over here at -3, it's multiplicity 1, so it's crossing. So now, if I know it starts up here, I say cross, bounce, bounce, down. Now I have a better idea of what the graph actually looks like. Okay, we did all of that in 2.2, right? And then yesterday, what else did we talk? Oh, yesterday we did the regression stuff, right? Okay, so there's a lot in 2.2. This is the next concept, which is actually writing the equation. So on worksheet 4B, we're going to do number 1 together. And it's showing us zeros at -2, at -4/3, and at +1/3. And it's telling us up here another point exists at 0, 16. So we have to write an equation for this. Can anybody start me out? If there's a 0 at x equals -2, what is a factor of this? Okay. If there's a 0 at -4/3, what is a factor? Now, you could probably also write that 3x plus 4, but it'll take care of itself eventually. Okay, I promise. And if there's a 0 at 1/3, x minus 1/3, okay? I don't know, some of you still are struggling with finding the stretch. I think our worksheet today or eventually calls this K. It's A, I don't care. A, K, whatever you want to call it, it's the stretch. okay? The stretch. What other points can I put in that would show me the stretch? Yes. I have this ordered pair of 0, 16 that's going to show me the stretch. So where am I going to put all those values in? For 16, or Y, I'm going to put in 16. We'll leave the K. And then for all these X's, I'm going to put in 0. So 0 plus 2, 0 plus 4/3, 0 minus 1/3. And if you need to write that out with the 0 in there so that you know how I got that, we were putting the zeros in there. Probably should have written it out that way. All right, can somebody, this is a 2 over 1, so what do we get on top? 2 times 4 times -1 would be? Okay. On the bottom, we have 1 times 3, which would be 9. Okay. All that's multiplied by the K value to get 16. We want to solve for K, so what do we need to do? Yep, multiply by the reciprocal. So over here we get K equals what's 9 divided by -8 times 16. -18. All right, so we can go back and plug this in up here for K. Now, there are several things we could do. That's not the only right answer. Does anybody know what we could do to write that differently if we wanted? This is fine. This is how I would leave it. But you could distribute a 3 through this parenthesis and a 3 through this parenthesis. Anybody know what that would change this to out here? Nope. What's 3 times 3 if I distributed 2 separate 3's? 9. So this would become a -2 out here. Okay. All right. I just want to show you. I'm going to need somebody to tell me what we just wrote real quick so we can check this because I want you to see that it works. By the way, guys, this is super important for this particular quiz. When you go to graph something and you're looking at the y equals graph only, you have to turn this plot off, okay? Super easy to just arrow up and hit enter and go back down. But it won't trace and do things nicely if you have a plot turned on. All right, it was -18 x plus 2 and then x okay. Let's try to set our window up to look like theirs. Theirs goes from what? -4 to 2? -4 to 2. And then the y's are, okay, I'm just setting it up to match what's on their graph. So the question is this look like what we have? If I do trace -2, it's crossing there. What would be the one point that I should probably check? The 0, 16 to see if that worked. If I type trace 0, it's going through 16. Seems okay? All right, any questions? All right. What I started to say was, I think if I put the -2 out here and x plus 2, and then I distributed a 3 through here, so it would be 3x plus 4, just to look nicer. And I distributed a 3 through here, so it'd be 3x minus 1. Okay, watch my graph. I think those should be the same if I put it in correctly. All right, so it's the same graph. I just wrote it differently to look prettier. Either way, leave it in factored form. Do not attempt to FOIL all that together, okay? That would be a waste of your life. All right, let's try number 4. Okay, this is really important. Please be paying attention because this is like the one on the quiz. There's some weirdness going on. Anybody see where the weirdness is going on? What are you going to have to know about the 0 at -3? Yes, it's multiplicity even. Okay? Which means we're going to use 2 because we don't really want to use power 4 or 6. Just be wasting our energy. Over here, this is also even because it's bouncing. Even multiplicity, okay? And where's the other 0? I don't know why, but students always forget this one. They just ignore it. Yeah, it's going through 0. All right, so tell me what you know about this so far. We're going to have y equals some k times. Good job. Tell me something more about that one, though. The even multiplicity means it's got to be squared, or to the 4th or to the 6th, but just do squared. All right, what else do you want? Okay, or you could have just put an x out front, right? And the other one? X minus 5/2, okay? And it's got to have a squared because it's bouncing. Okay, bounce, or kiss, if you want to call it that, kiss or cross, but means multiplicity 2, or 4 or 6. Okay. Now what? We still have to find k. Yes, we need to put a point. The problem, guys, is none of these points here have a stretch because they're all on the x-axis. Anybody see where they give us another point to use? Yep. So at 1 over here, this graph is apparently at -28.8. So we're going to put that in. We'd have -28.8 equals k times 1 plus 3 squared times 1 plus 0 times 1 minus 5/2 squared. -28.8 equals k times, what is 1 plus 3 quantity squared? 16 times 1, which is going to do nothing, times 1 minus 5/2 would be -3/2, but remember when you're squaring it's going to become positive, right? Yep, 9/4, good call. And you can use your calculator to do all that. Over here we have 16 times 1 times 9 divided by 4. My little pea brain is getting 36. Somebody tell me if that's wrong. Okay, now what? Divide. And I don't know what that is. Fraction maybe? A decimal, -0.8 would have been fine too, as long as it's exact. You just don't want some long repeating or crazy decimal because that won't work. So where's our final answer? Yeah, we got to go way back up here and erase this k or rewrite it and put in a -4/5 for our stretch. Now, are you going to be okay if I don't type that into the check it on the calculator, or you want to? You all right? Okay. So you have 3 of those to finish. Okay? Any of them you looking at? You need me to help you think about any of those? This one, remember, it's going to have a bounce here. So you're going to have an x what? Okay, x minus 2 squared. And over here, if this is at -3, you'll have x plus 3, and now you need to find k by plugging in this point. Okay, that wasn't so bad, right? Any of them look crazy, need more help or not? Try the other 3 tonight for homework. This one and the other 2, right? Numbers 2 and 4 maybe? Is that the ones I didn't? 2 and 3? Okay, 2, 3, and 5 you need to finish. Okay. All right, the next thing we're going to talk about is side A on worksheet 5. And it is your very favorite thing from last year. It is long division with polynomials. There is, okay guys, this says, do you remember how to do long division? And I gave you a hint that you need to remember this because there are 2 parts to the SAT math. One part is no calculator, okay? Now, we're going to review this because the process is the same with polynomials. So first we say 6 goes into 2, doesn't work. 6 goes into 29. We say 4 times. Guys, please be paying attention. 6 times 4, that's important. We multiply, right? Multiply. We get 24. Then we do what? Subtract. And then we bring down. So we multiplied, subtracted, no. And then we brought down. Okay? And then we divide again. Goes in 8 times. We multiply. And we subtract. And then if we decide to stop there, we have a remainder of 5. Do you remember how to write that as a fraction, anybody? It actually goes over this divisor out here, so it would be 5/6. Anybody remember that now? Maybe? Okay, does anybody remember how to check this problem? You would do 6 times 48, but then you would do what with the remainder? Add 5 onto that, and it should come out 293. Okay? Lot of important stuff we just talked about there. All right, so let's try it one more time. 22 goes into 38 once. We multiply. We subtract. We bring down. Okay? Then 22 into 162. Sometimes we kind of have to take a guess. Well, 5 times 22 would be 100. 5 times 20, I'm rounding to 20. 6 times 20 would be 120. 7 times, it might be 7. If we do 7, 7 times 2 would be 14. 14 carry, add a 1 would be 15. Did I do that right? Is someone checking me? Yeah, sometimes 2 times 7 is 14. Only sometimes. Okay. Now we have to subtract. Is 8. Bring down the 4. You thinking 3? And that would be 66. And we subtract. And you got 18. Okay, you're faster than me. Now, we could write remainder 18, or we could write what? It's plus 18 over 22, or would be 173 and 9/11. Does that seem right to anybody? Does that reduce? Okay. And how would I check it? No, 22 times 173 and add 18 on, and it should be 3824. All right. Let's try this. The top of your worksheet, it says you can divide polynomials using either long or synthetic division. Okay, the problem is you can't always use synthetic division. The process of dividing polynomials by using long division is similar to arithmetic, where we just did. It is dividing, multiplying, subtracting, bring down. To set up long division for polynomials, be sure the dividend is in standard form and placeholder and with placeholders for missing terms, okay? The vocabulary, guys, this is the dividend. This is the divisor. And this is your quotient. Just in case you don't remember the vocabulary. This placeholders for missing terms business means if your dividend in here is 8x cubed minus 6, okay, you need to put some zeros in. What factors or powers of x are missing? 0x squared and 0x would need to be placeholders in there. Kind of remember that, maybe some of you from last year? Okay. Synthetic division is a shortcut and it only works when the divisor is like x minus or x plus something, okay? Meaning there's no leading coefficient on the x and it doesn't have a power greater than 1. Like if you have divide by an x squared, you can't do it. All right, so this is one that actually we could do synthetically, but we're going to do it by long division. It's already done on your notes, so all eyes up here, just help me. As soon as I wrote this down, I had to put what in? Okay, 0x squared had to act as a placeholder. Gentlemen. Now, what we do is we look only at this first term and the first term here. You are looking to multiply. What can I multiply x by that will become exactly 3x cubed? Okay? Everybody good? 3x squared times x is going to be 3x cubed. But then you're multiplying it by all of this. So we have to also multiply the 3x squared times 1, and we get plus 3x squared. This is the step that everybody messes up because what we do next is we subtract. And as soon as we subtract this, everybody forgets that this is going to become what now? Yes, we're going to add the opposite of this, which will make 0, and the opposite of this is going to be a negative 3x squared, and that's where people make the sign mistakes usually. Then we're bringing down what? Negative 2x. But we're only looking at, again, this first term here and this first term here. What do we need to multiply x by to make it become exactly negative 3x squared? Okay, so distribute that over here and we get a negative 3x squared, and a negative 3x times 1 is a negative 3x. But remember, we're doing what? We're subtracting those, which means adding the opposite. So what is our leftover back here? A positive 1x, and we bring down a minus 4. Okay, one more time. What do we multiply by to get x to become exactly x? 1. Positive 1. So 1 times x plus 1 will just be an x plus 1. Be careful. Now what? Subtract that. So what's our remainder? So many people get to the very end and mess up the remainder. Distribute the negative here. This is going to be plus, negative, negative, and we're going to have negative 5. All right. The check, if you were doing this on a quiz, would be to take your divisor, multiply it by, take your quotient, multiply it by your divisor, and when you're all done, add that negative 5. I'll do this really fast, okay? If I distribute the x through this parenthesis over here, I'll have 3x cubed minus 3x squared plus x. If I distribute the 1 back here, I'll have plus 3x squared minus 3x plus 1, and I have a minus 5 I'm supposed to do on the back. If I combine like terms, I have a 3x cubed, Those go away. I have a minus 2x, combining those, and a minus 4. Is that what we started with at the very beginning? Okay. Now, as far as writing an answer, you could say this was your answer with a remainder of -5, or you could say 3x squared minus 3x plus 1, and then you're adding that divisor divided by, remember the fraction business? It was this over this. Okay, so you can write it like that. It's going to ask sometimes, yeah, for this way. All right, so synthetically dividing. This one is done for you again. The synthetic division thing, you might want to write yourself a note. When you're dividing by this, instead of writing 1 here, you write the 0 for that. What would set this equal to 0? So you put a -1 in that box. Across the top go the coefficients only, but you do need a placeholder. So the coefficients were 3x cubed, 0x squared, -2x, and -4. Ready? Good? And then the rule is bring down the first one. And then it is multiply, add, multiply, add until you're done. Okay? So I bring this one down. -1 times 3 is -3. I add straight down. I multiply. -1 times -3 is +3. I add straight down. I multiply. -1 times 1 is -1, and I add straight down. Was our answer, okay, wait a minute. Let me back off that for 1 second. What we just did, the last one is always the remainder, okay? The last thing we end up with is always the remainder. Then you go backwards. This is important. You go backwards and you say this is the constant. This one gets 1 power of x. This one gets 2 powers of x. So our answer was 3x squared, just kidding, minus 3x plus 1 with a remainder of -5. Or 3x squared minus 3x plus 1 minus 5 over the divisor, which was x plus 1. Yep. Is that the same thing we had a minute ago? Okay. I don't know about you, but I'd always choose synthetic if I could. Okay? You can't. Remember, it said it's only if it's x minus a number or x plus a number. What we're dividing by here has a 2 out in front, so we have to do long division. Everybody ready to try this one? Where we write what? 2x minus 1 goes outside. Dividing into 2. Do we need any placeholders for this one? X cubed plus 3x squared minus 8x plus 3. Okay. I can guarantee somebody in this room is going to come to me after the next quiz and tell me I have no idea how to do long division. Please be paying attention here, guys. Okay. We multiply something by 2x, and it has to become exactly 2x cubed. Right? Now, when we multiply that, we're going to multiply it by both of these terms. So 2x times x squared is exactly 2x cubed, but x squared times that -1 is a minus x squared. Then remember you're subtracting. So you're going to subtract 2x cubed minus 2x cubed, but you're going to do what back here? You're going to end up adding 1. So we could change the signs if you want. I usually use 2 colors when I do these so that I make sure I change the signs. Now I'm adding because I changed the signs. So this is 4x squared minus 8x if I bring down this term. All right, I need 2x out here to multiply by something that I write up here to become exactly 4x squared. Okay. Now I multiply that 2x by both of these terms out front. So I get 4x squared, but then I get 2x times -1 is -2x. Now when I go to subtract, I'm adding the opposite. So what do I get back here? -6x, and then I can bring this +3 down. Okay. 2x will be multiplied by what out here to become, by something I write up here, to become exactly -6x, -3. Multiplying both of the terms out here by -3 will give me -6x plus 3, which if I subtract, will change this and be exactly 0. So my answer is x squared plus 2x minus 3. How could I do a check if I wanted? I could take that x squared plus 2x minus 3 and multiply through the 2x minus 1, and I should get what? Yes, 2x cubed plus 3x squared minus 8x plus 3. I won't take time to do that, but that's how you would check it, okay? Oh, joy. Here we go. It's not as bad as it looks, I don't think. I could be wrong. Do we have any placeholders? Which ones go in inside the box? 2x cubed plus 5x squared minus 7x plus 6. Okay, out here we have 3 terms this time, a trinomial, x squared plus 3x minus 4. All right, who thinks they can talk me through this one? Okay, Bun, you got this? Okay. Okay. We're going to multiply so that it becomes exactly 2x cubed. So when we subtract, it will be 0. I knew what he meant. Okay. So what do we got to multiply by? Okay. Can you multiply that 2x by all 3 of these terms out here for me? Okay. Then this is where we have to be really careful because we are subtracting each one of these terms, or adding the opposite of this, the opposite of this, and the opposite of this. So this is 0. That was our whole point here. What happens back here, though? Job. Yep. Okay. Now what? Sure, if you want. Okay. Tristan? Okay, we need this from this, so we're going to multiply by a -1. Good call. What will we have? Okay. Then we need to go back and subtract or add the opposite if I change all these signs. Anybody tell me what I get then? Okay. Are we done or you need to go again? We have an x squared out here, So to get a 4x, you'd have to multiply by like 4 over x, and we don't do those, okay? So we're good. So can anybody tell me how to write the answer with a fraction? 2x minus 1, 4x plus 2 over, whoa, x squared plus 3x minus 4. Now be really careful. It is plus, and be careful because sometimes students will, if there's a negative up there, it gets a little, so just put a parentheses around that one. All right. So if we wanted to check, we'd have a big old mess, right? We'd have to multiply these two together and then add this to our answer. All right. This is extra practice. How about we do that one for a warm-up tomorrow? Does that sound okay? Let's go and talk about synthetic division quick. We're still on the same side, right? This one, number 3? Yeah, we're still on the front. Okay. This is just, you don't have this. This is just how you do synthetic division. One more time. When it says divide by x minus 3, what goes in the little box is actually 3. It's the 0. And then the rule is bring down, multiply, add, multiply, add, multiply, add, and the last one is the remainder. By the way, this has a great name. This little guy that's left over down here is called the depressed polynomial. He's really sad, I guess. I don't know. Okay? So the depressed polynomial, remember the back one is the constant. Then you'd put in an x and an x squared. So for this example they have here, 6x squared minus 7x minus 3 is the depressed polynomial. All right. We are going to try this one. Anybody think they remember how to do this? Negative 4 goes in the box. Good. 1. Oh, he's good. Why is there a 0? Because there's 0 x squareds there. It's in standard form, so this is degree 3, 2, 1 constant. All right, now what? Bring down the 1. Negative 4 times 1 is, and that gets written up here. Add, not subtract, add. Multiply. Add. Negative 12. Okay. Multiply. Add. Okay. The last one is always a remainder, so this one went in evenly. What is our depressed polynomial, or our answer written as a polynomial? Yes, this is a constant. This one gets an x and an x squared. So it's x squared minus 4x minus 12. If I wanted to check, I would do what? Multiply that by x plus 4, and it should come out x cubed minus 28x minus 48. If I wanted to do a check. Okay? One more? Who wants to try this one? Go ahead, Tristan. What do you want to do? Okay. 1x to the 4th. 0 for x cubed. Negative 3 for x squared. 0 for x. Good call. You remembered. And then a 12. All right. This guy just comes down, and then we multiply. Multiply. Add, so it's still -2. Multiply is -2. Add is, okay, so answer is, see, this one gets an x squared, x. So x cubed plus x squared minus 2x minus 2. Okay, if we had to write this 10 as a fraction, anybody know what that would be? Austin, you're kind of scaring me today. This is tricky stuff. You should be paying attention and taking good notes. Okay. If it said you had to write it as a fraction, that's what it would look like. All right. Hang on one second. I want to show you what I want you to do for homework. I want you to only... Okay. To do... Oh, look here. I even did it last year the same way. Do these 4 questions. Okay. And the rest of worksheet 4B plus worksheet 4B. Okay? Those 4 problems are listed on your homework check sheet or the blue sheet, or you can just write them down. And don't forget to go back and do 4B. I cannot stress enough, this would be the day to do homework. Neither of these 2 things we did, worksheet 4B or this division stuff, is stuff you're going to be good at by just watching me do it. Okay?